So this is how you would make round robin work exactly like FIFO. So suppose that, or even like shortest job first, if you have equal sizes for the jobs. So suppose that you have um, again tasks or jobs each of requiring 5 time units to run. Uh, if you are doing round robin with 1 millisecond time slice or 1 second or whatever the value is, then you will basically keep context switching until one finishes, two finishes, three finishes, four finishes, and five finishes. But then if you make the time slice equal to 10 time units, okay, this is even more than what the task would need. That means that task A would run to first task would run to entirety, then stop because, well, I'm done before even the time quanta has passed. Then second task, then third task, then fourth task, then fifth task. So if you increase the time slice by large to a large number, basically you end up with FIFO. So while round robin does well for response time, it is actually terrible for things such as turnaround time. The shorter the time slice, the better it is in general for round robin, in the sense that your response time slash your waiting time will be minimal because you will have to wait for a really short time slice before you get scheduled. But then there's an overhead of context switching because basically changing between jobs. When we were talking about how the kernel handles context switches, we talked a lot about moving the uh, moving the process stack, moving the uh, moving the different process data, user data basically into the kernel stack, and how does this happen. So there is a large overhead into that. So if your time slice is too small, that means that context switching will become very expensive. So looking at this figure, you see that I mean, if you're calculating the turnaround time, then you have jobs A, B, and C, then, well, if you use SJF or STCF versus if you use round robin, you calculate the turnaround time, you will have SJF taking 10 seconds. Okay, this is the average response time. Sorry, this is the average turnaround time. Uh, and while the average turnaround time uh, for round robin is 14, which is actually almost as bad as 15, almost as bad as the total time required to run all three jobs at the same time. So, as anything in life, there are multiple trade offs, and these are inherent in all scheduling algorithms. You'll find them when you're scheduling in life, and you'll find them when you're scheduling for anything. When your whole life is basically you scheduling tasks. What do I do now? Do I just go and travel the world, or do I take my bachelor's in CS? I mean, these are two different options that one can do, even if he doesn't have money, by the way. But each one of them has like gains, some different gains. Um, so depending on what you value the most in your CPU scheduling, now not in your life, but in CPU scheduling, you'll pick your algorithm. So if you are willing to be unfair but have very good very good turnaround time, especially for shorter jobs, then but this comes at the cost of waiting time for longer jobs, then you'll definitely go with SJF or one of its like variations like STCF. If you instead value fairness, then you will go with for round robin. So, another question: which of the following is true about the scheduling process that we have discussed so far?